So this is the first part. I'll post this and it'll be 7.3 part 1. But I'm going to record this lesson. So if you guys have any questions as we go through, you may, and that's okay. You just go ahead and jump in and ask. But this is the sine curve, right? We're going to talk about sine, cosine, tangent, cosecant, secant, and cotangent. But today all we're talking about is sine and cosine. Those are our two basic. Okay, we're going to have a sine curve and a cosine curve. And we're going to talk about different vocabulary as an amplitude or time period, stuff like this. But this is what your normal sine curve looks like. When I talk about one period, I mean one revolution around the unit circle. So from 0 to 2 pi. So this is considered right here. This is considered one time period in the sine curve. And then it's like a wave. It just repeats itself over and over and over again. So as you see, it starts here at 0, 0. And then it ends here at 2 pi. That's one revolution around the circle. Does everybody see that? Okay, sine curve. This is what it looks like. Here's our little tick marks. We'll talk about that more. I just want you guys to see kind of what that looks like for you. All right, so moving along, this is the cosine curve. This one looks a little different. Okay, again, we're going to talk about a time period. So here is one time period, one time around the unit circle. If you guys notice, this one started up here on the y-axis. It didn't start at 0, 0 where our sine curve did. So that's an important thing to remember, that your sine curve, the parent function, starts at 0, 0. The cosine curve starts at 1. Over here, it talks about range. Range is just how high and how low your curves go. How tall they are, if you want to look at it that way. How fat they are, if you want to look at it that way. Range is on the y-axis, you guys know, it's up and down. But when we talk about our trig graphs, they're called amplitude. Same thing, okay? I'll write this down in a second as we go through. So when we have our two key points here. All right, so if we look at our two curves down here, all right, these are things that we need to remember. And you might want to write this down because these are good things to look at. Here is my sine curve. On the left here, this is my sine curve. If you notice, this is the parent function, guys, parents. We're going to transform them. We're going to move them up and down, left, right, that sort of thing. But a sine curve, the parent function starts at the x-axis. It starts at 0, 0. And it starts here at 0, 0. And when it's a positive, and you'll see what I mean by that in a second, it goes up. So you're going to go up to the first tick mark that you have. Then you're going to go down to the x-axis. Then you go down to the tick mark, then back to the x-axis. You just keep repeating that pattern. That's how that works. Does everybody see that? The intercepts would be where they cross the x-axis, which would be here at the halfway point, in between whatever the time period is, and then at the end of it. So it starts at the beginning on the x-axis, then at the halfway point it hits the x-axis, then at the ending it hits the x-axis. And the amplitude here for the parent function is always 1. The highest it goes is positive 1, and the lowest it goes is negative 1. So our amplitude, if they ask for it, would be 1.
Is the amplitude always positive?
It's always positive and negative. It's always going to be, whatever, say the amplitude is 2, that means the highest it's going to go is up 2 and down 2. Good question. And you'll be able to see that from the equation that they give you. This will make a little more sense once you see an equation. Yes, ma'am?
Brianna's iPad crashed. Can you let her back in?
I just did, yeah.
Okay.
Thank you.
Good morning, Miss Meadows.
Good morning, honey. All right, so now if I look over here at the cosine curve, do you guys see how this one looks a little bit different? This is our cosine. This is the parent for the cosine. This is our parent function. Remember, we have parent functions and we do all sorts of stuff to them. But if you notice here in the cosine, it starts up here at positive 1. And it ends at positive 1 up. See how it doesn't end on the axis itself? It ends up at the amplitude. If it's positive. If it were a negative graph, it would start down here at the negative amplitude. And again, I'll show you that in a second. This graph starts up on the y-axis, then hits the x-axis, then goes down, then hits the x-axis, then goes back up. But you see how the curve is different looking. And your starting point is where it's going to really tell the difference between a sine curve, and a cosine curve. All right, so let's look at this one. When we talk about maximum and minimum values, you guys can see that on a graph. Don't get too concerned with this right here. This is confusing, but right here, amplitude. Hayden just asked, is amplitude positive or negative? It's the absolute value. So say you have a picture, you got this curve. What kind of a curve is this, just by the way that I drew it? Anybody?
Sine curve.
Why is it a sine?
Because it starts at 0, 0.
Very good. Starts from the x-axis. What would the amplitude be here? What's the highest and lowest that this graph goes?
3.
Yep.
3 and negative 3.
Mm-hmm. So you would just say your amplitude is 3. Just your height, how high and how low it goes. The higher the amplitude, the skinnier that your waves are. The smaller the amplitude, the fatter it is.
Do they have to always be opposites, or can you have like a positive at 3, like 3 or 3, and then a negative at like negative 5?
Very good question. It's always going to be, okay, let's do it this way. Your amplitude is always going to be the same. It's always going to be a mirror image of itself, the high and low. Now, if I shifted this graph up, you'll see what I mean by shift in a little bit. If I shifted it upwards, then the graph would look different on your axis, but it would still go up 3 units and down 3 units. It'll always be the same. Good question.
Okay.
Good question.
So it can change. So
it can change the way it looks on the graph, but it won't change the equation. I'll show you what I mean by that in a second.
Okay.
Now, you're going to see this in a second. This is going to be probably the hardest part that you have to look at, but you're going to be asked about a time period. And I told you at the beginning, a normal time period is 2 pi. It's one revolution around the x-axis. Well, when you are asked to find the period, you always take 2 pi. Take 2 pi right here. And you divide it by whatever number is right in front of x. Okay, so when you are looking, and this, I promise you, this will make more sense once we have something right in front of us. But our amplitude is always going to be the number that's in front of our function. So if it said 5 sine x, your amplitude would be 5. Goes up 5, down 5. If it said negative 2x, it would be 2, up 2, negative. And we'll talk about what the negative means be. But what you do to find the time period is you divide 2 pi by whatever is in front of the x value. And again, I'm going to explain this more with an actual equation and it'll make more sense. But you need to find all the quarters. We're going to find each quarter. There's going to be 3 tick marks. Actually 4. You're going to have 4 little tick marks to tell you where your curve is. So let's look at an example. Well, we'll talk about reflection. All right, what does a reflection do? Look at it.
Flips it.
In a positive sine curve, you start here and you go up, right? So in a negative, would it make sense that you start and then go down? Do you see where that negative is? That would be the same as if I had negative x plus 2 squared, correct? If I had negative x plus 1. If I had negative x plus 3 cubed. Whenever we had a negative out in front, it flipped it over the axis, correct? Same exact thing. So, we'll talk about vertical translations. What does it mean to vertically shift up or down? What does that mean?
To move it up or down on the y-axis.
Y-axis. So let's look at an example, okay? We're going to find the amplitude on all of these. I'm just going to do a bunch of examples. We're going to find amplitude. We're going to find the time period. And we're going to find any vertical shifts and reflections. This is easier if we just kind of look at an example. Now, the first thing I want you to do is identify if we're talking about a cosine curve or if we're talking about a sine curve, because where you start makes a difference. A cosine curve starts on the amplitude. A sine curve starts at the x-axis. So what kind of a curve do I have here? What kind of a curve is this? Sine or cosine?
Cosine.
Cosine. So this is a cosine curve. So you can tell yourself right now it's going to start at where? Does the cosine start at the x-axis or does it start at the amplitude?
Amplitude.
At the amplitude. So it's going to start at amplitude. All right. Amplitude is the number that's way in the front. It's kind of like your vertical stretch. So what is the amplitude of this graph? What's the highest and lowest that it goes?
4.
4. Positive 4, negative 4. So my amplitude is 4. Does that make sense? Yes or no? Hello?
Yeah.
Okay. So let's talk about a vertical shift. A vertical shift is just like if you had this, x squared plus 7. That's a parabola, and where does it move?
Up 7.
Up 7. So do you have any vertical shifts here on this cosine graph? Does it move up or down the x-axis at all?
No.
Nope. So there's none. A reflection is going to be a negative sign in front of your function. Is there a negative sign in front of your function?
No.
No, there's none. And then the time period. Remember, for the time period, you take 2 pi and you divide it by the number that's in front of x. What number is in front of x?
4.
No, right in front of x.
1.
Just one.
1.
Just one. So my whole time period here is 2 pi. Does that make sense? Yes or no? You guys with me at all? All right.
Yes.
So if I was going to graph this, okay, I know that I start here at 0 and I end at 2 pi, right? Because that's my time period is 2 pi. One whole time around the unit circle. Now I got to find the quarters. I got to find the pieces in the middle. I got to find the 15, 30, 45, 60 if I was thinking on a clock. So to find those little tick marks, you just take the whole time period, which is 2 pi, and you divide it into fourths. So 2 pi divided by 4 is what?
Pi over 2.
Pi over 2? You guys agree? Yes or no?
Yes.
Okay. So that means this first tick mark is 1 pi over 2. That means the second tick mark is how many pi over 2's? 2 pi over 2.
Okay, Mom, that one, now can we her iPad?
You want your iPad?
Yes,
Hang on one sec, guys.
that was-
Sorry, guys. So then the third tick mark would be how many pi over 2's?
3.
3 pi over 2's. And the last tick mark would be how many pi over 2's?
4 pi over 2.
4 pi over 2's. So to find the time period, you just take the whole time, the little tick marks, you take the whole time period and cut it into fourths. Now go through and can you simplify this? Can I simplify pi over 2? No. Can I simplify 2 pi over 2?
Yes.
Yeah, what does that become? Just pi, right? Can I simplify 3 pi over 2?
No.
No.
No. Can I simplify 4 pi over 2?
Yeah.
Yeah.
Yeah, that's 2 pi. That makes sense? Ish, a little bit. I know this is kind of like, what? It's just different. So if I asked you guys to give me a graph of this, the first thing you would do is you'd find your little tick marks. That's good. Now you would tell me, what's the amplitude? What did we say? What's the highest this graph goes and the lowest it goes?
4 and negative 4.
Okay, so 1, 2, 3, 4. 1, 2, 3, negative 4. All right, and this is a cosine curve. So do we start at 0, 0, or do we start at a 4?
Start at 4.
We start at 4. Why am I going to start at positive 4 versus negative 4?
Positive 4 because that's what it says in the equation.
Okay, but
And
there's
it's not a reflection.
There's no reflection. Good. If it was -4, you would start at -4. So I'd put a dot right here. There's my first dot. And then I put dots at every single little time period that I have. So I go to the x-axis, then I go down, then I go back to the x-axis, then I go up. And then I could just like draw my smooth little curve. It should be a curve. You should connect all the dots. I didn't, but I was close. Now, guys, this is brand new. I understand. Some of you may have seen this in Algebra 2, but some of you are looking at me like I have 14 heads. Are you okay? That's why I'm not doing all this at one time.
Yes.
Okay. All right, let's look at the next one. Okay, we can tell ourselves a lot of stuff here. Let's talk about the amplitude. Let's talk about the time period. If there's vertical shifts, reflection. That's it, right? Okay, what kind of a curve am I starting with?
Sine curve.
Sine curve. So that means this is going to start where?
At 0, 0.
It's going to start at 0, 0. We'll say start at the x-axis because as we move them left and right and stuff, they're going to move. So we'll either say starts at amplitude or starts at x-axis. Oops, I forgot to write the x. All right, so what is the amplitude? What's the highest and lowest that this graph is going to go?
2 and -2.
2 and -2. So it's just give me the absolute value. So you're going to say the amplitude is 2. Now the time period. Remember, find the time period. You say 2 pi divided by the number that's in front of x. What number is in front of x?
1.
One.
Negative.
Nope.
In front of x, 1.
So your time period is going to be one whole circle. So those tick marks are real easy to do because it's the same as what you'd have on the unit circle. Vertical shifts. Is there anything at the end that's being added or subtracted to our graph?
No.
No. So there's no vertical shifts. Is there a negative sign out in front of my function?
Yeah.
Yes. So there is a reflection here.
Reflection.
It's going to reflect over the x. So if we were going to graph this, guys, first thing I would tell you to do is your amplitude. What's the highest point? What's the lowest point?
2 and -2.
Okay, so +2, -2. Good. What's the time period? What do I start at? I start at 0, and I end at what?
You start at 0 and then go to 2 pi.
And I go all the way to 2 pi. So I got to find all the 3 little tick marks in the middle. So remember, I'm going to take my 2 pi and cut it into 4 pieces. Gives me pi over 2, correct? So this
Yes.
first tick mark is pi over 2. What's the second tick mark?
Second tick mark is 2 pi over 2.
2 pi over 2. The third tick mark is 3 pi over 2. And then the fourth tick mark is 4 pi over 2, which is 2. So the only thing you need to simplify is the 2 pi over 2. Don't leave it like that. So this would be just pi. Everybody with me?
Yes.
Everybody okay? All right. Now, I have a cosine or a sine curve. Sine. So we already told ourselves at the beginning that we start at the x-axis. So I'm going to start right here at 0, 0. But since it's negative, which way do I go to do my first point?
Down.
Down. So I'm going to go down right here to the first tick mark. Then I go to the x-axis. Then I go up here. Then I go down. And then I draw my curve. How is it? Borja, you with me? You guys okay?
Yes.
Okay, I know. That's why we're going to take this slow. I think I'm going to move the quiz to next Monday. I'll talk to Mr. Rivera. All right, I want to do a little bit, two more, and then we'll be done. All right? Here we're going to find, again, the same things. We're going to talk about amplitude, time period, vertical shifts, reflection. Now, think about all of the things I told you guys you can find just by looking. The first thing you're going to tell yourself is, what kind of a curve am I talking about? What kind of a curve?
A cosine.
It's a cosine. So that means we're going to start at the x-axis or amplitude?
Amplitude.
Amplitude. Good. All right, now this is a tad different. What do you guys notice about this equation?
That you have to add the number.
I like that. It says 2 plus. If that 2 is not right in front of the curve, the function. What number is right here in front of the function?
1.
1. So our amplitude, guys, is 1. Our time period, we take 2 pi and we divide it by the number that's right in front of the x, which is what? What number is right in front of x? 1. So I would have just 2 pi. So what do you think that 2 plus is at the beginning?
Vertical shift.
It is a vertical shift. If I moved it to the back, it would say cosine x plus 2, right? So just because it's in the front, it still means the same thing. So where are we going to shift this graph?
To the right.
No, vertical.
Oh. Opposites.
It's going to go up. How much? 2.
2.
Is there a reflection? Do you see a negative sign right in front of the cosine?
No.
No, so no reflection. So when you're graphing and you have to do a vertical shift up and down, this is how I think you should do it, because I think it's easier this way. The first thing I'm going to do is I like to draw the parent function always, and then I do the shifts up and down, just because it's easier for me to see. So the first thing I'm going to write down is my amplitude. What's the highest and lowest that this goes?
2 and negative.
No, what's the normal amplitude?
1 and negative.
1 and negative 1. So I'm going to write a 1, and I'm going to write negative 1. Okay? Now the time period. It's 0 to what?
2 pi.
2 pi. Good. So I already know what my tick marks are. It's going to be pi over 2, pi, and 3 pi over 2. It's been that same way every time. It's not always going to be like that. Not always going to be like that. So from this point, guys, I would graph the cosine graph without the vertical shift. If it's cosine, where does it start again? Remind me where it starts.
At the amplitude.
At the amplitude. So I'd start right here at 1, and it's positive, right? So I start at positive 1, then I go down here, then I go here, then I go here, and then I go here. You guys agree with me that that's what my curve looks like? Mm-hmm. Okay? The only thing I forgot, though, or that I didn't do, is I didn't do the vertical shift. The reason I do the vertical shift second is because, do you see how I already have my points on my graph? I can already see where my points are. You guys see that? Yeah. If I vertically shift this graph up 2, that means every single point that I drew goes where?
Up 2.
Up 2. So this one right here at 1, I'm just going to rewrite it, and I'm going to go right there, up 2. So this one here at the x-axis, I'm going to go up 2. This one here at negative 1, I'm going to go up 2. This one here at the x-axis, I'm going to go up 2. And this one here, I'm going to go. So do you see my cosine curve that's positive, that's shifted up 2? Do you see it? Yes or no?
Yeah.
Okay. That's the hard part. The hard part of this, the harder part is going to be on next time I see you. Next Monday. Shifting it left and right. That's where it's a little more difficult. Because you'll see, whatever. But what I think you should do is whenever you have a vertical shift or horizontal shift, I would graph without the shifts first and then move it, and it's easier to see. Now, some people can do this in their head, which is great. I can't. That's just not my forte, so it's just easier for me to do it this way. Is that okay? Yes, yes, yes.
What we'll be doing Friday? Like, are we still gonna work on this more?
Fridays aren't really like academic days. You can ask me any questions you want, but I only have you for like 15 minutes. So if you want to ask me about anything on here, that's fine. Nunez, whatever.
Okay, cool. So on Monday, you said we're just gonna keep working on this then. Like,
Monday is that? Am I talking to Matt or Vincente?
Yeah, Matt.
Okay. I'm going to do one more thing with this on Monday. We're going to do shifting it left and right, or horizontal shifts. Which, let me just show you real quick. I know I'm getting off a second, but just say I went like this. Well, in a second. I'll talk about that in a second. Let's do this last one and then we'll be done. But yeah, and then we'll practice it a little bit more on Monday, and then we'll practice on Wednesday, and then we'll do the quiz the following week, like maybe May 4th week. We'll do it then.
Okay.
I know. Yeah. I'll talk to Mr. Rivera. We'll switch it. Okay. All right. Here we go. We got this, guys. We're going to talk about amplitude, time period, vertical shifts, reflection. All right. First thing you're going to do every time, and I know I keep saying the same thing. I'm trying to get it in your brain. What kind of a curve do we have?
A sine.
It's a sine, so that means I don't start at the amplitude here. I start at the x-axis. All right, that's a good thing to remember. So what is my amplitude? What is the number right here in front of sine?
1.
1. My time period is going to be 2 pi, and I divide it by the number that's in front of x. What is that? 1, so it's just going to be 2 pi. Now, guys, it's not always 2 pi. I don't know why all these examples are turning out like that. But what does that minus 1 represent?
Amplitude.
Nope. Our amplitude's right here.
Vertical shift.
Vertical shift. Good. Very good. Where is this going to go?
Down 1.
Perfect, Borja. Good job. Down 1. And is there any reflection? Is there a negative right in front of my curve? My sine function?
Nope.
Nope. So let's graph it. Now again, you can do however you want. I personally like to graph the curves without any shifts. So I say my amplitude is 1, so the highest it goes and the lowest it goes is 1 and negative 1. Right? My time period is 0 to 2 pi. So I already know that, then my tick marks are going to be just like they are on a unit circle, right? This is 2 pi, so this would be pi over 2, pi, 3 pi over 2. It's the same thing. All you're doing is just writing it out on a line. So this is pi over 2, pi, 3 pi over 2. So if I'm going to graph this, the parent function, I'm going to graph that without my shifts left and right. I'm going to start where? Do I start at 0, 0, or do I start at 1?
1. Oh no, 0, 0.
Good. Our sine curve starts at 0, 0. So guys, if you had a multiple choice question, you could probably eliminate 1 or 2 answers just by the starting point of the graph, depending on what kind of curve you have. So it's important that you guys pay attention to that. But is this a positive sine curve or a negative one?
Positive.
It's positive. So my first tick mark is going to go up. So I'm going to put it right here. Then I'm going to come back down. Then I'm going to go down here. And then I'm going to go right here. So here is my sine curve. All right. Is this my final answer?
No.
Nope. Because what did this sine curve do?
Shift.
Shifted where?
Down.
Down how many?
1.
So every point that I have on my graph, what should I do with it? Move it down 1. So this one here at 0, 0 is going to come here. So this is here, 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 and here. And I just go, and there's my answer. Is this crazy hard?
No.
No. Is it a lot to remember? Yeah. So next week, if I had something like this, let's just say, okay, if I said to you guys, all right, tell me everything that's going on here and graph it. Instead of you guys freaking out, right? You can answer all of the things. All of the things. I have amplitude. I have time period. I have vertical shift. I'm going to add in horizontal shift. And then I have reflection. Now, just by looking at this, you guys can tell me all of the things, and then we can graph it. The first thing, what do I tell you to do every single time? What's the first thing you identify?
Sine curve.
Yes, sir. Sine curves. That means we're going to start where?
At the x-axis.
At the x-axis. Awesome. Good job, Hayden. It might be to the left or the right of 0, but we're going to start there. So this negative out in front, what does that negative sign mean? It's a what?
Reflection.
Yep, it's a reflection over x. So when I plot my first point, instead of going upwards, I'm going to go which way? It's the opposite of up. Down. Good. All right, 3. What does this 3 mean?
Your time period? No.
Is it the amplitude?
It is the amplitude. The highest it goes is positive and negative 3. Good. Time period is 2 pi divided by whatever number is in front of x. What's the time period here?
The 2 pi.
Yep, so it'd be 2 pi divided by 1, 2 pi. Good. Is there a vertical shift?
Yes.
What is it?
4.
Yep, we're going to go which way 4?
Up.
Up 4. Just like, guys, this is just like we've done a million times. The last thing that we didn't talk about. Is there a horizontal shift?
Yes.
Yeah.
Okay, look. Let's go back to algebra 2. F of x equals 3x minus 4 squared plus 1. What does this mean?
To the right 4.
Why is it to the right, Hayden? You are correct.
Because it's opposite.
It's opposite. Anything in the parentheses is opposite. So, guys, what is this horizontal shift?
Left pi.
You're going to go left pi. What that means, and that's what we'll get to in a second. Not in a second, next week. So here's my tick marks, right? If I move my graph left or right, let's just pretend this was right since I did this all positively. Or no, we can do it like this. If I move my graph, here's 0. If I move it to the left pi units, am I adding pi to it or am I subtracting?
Subtracting.
So what you would do, and this is where the hard part, not hard, but you'd have to say, okay, minus pi, minus pi, minus pi, minus pi, minus pi. So you're going to have new tick marks. Your new tick mark is going to be, there'd be one at negative pi. There'd be one at negative pi over 2. There'd be one at 0. There'd be one at pi over 2. And there'd be one at pi. So your graph, instead of starting at 0, it would start over here. And it would go like this. Just moving it to the left. And we'll practice that. But that's identifying it is just like you've done a million times in our normal transformations. Is that okay? Kind of gross?